Hello everyone. This is the new initiative that is the organic name reactions. Organic name reactions are asked in every board exams and university exams where organic chemistry is involved as a subject and as a paper. So question can be asked like write short notes on the following. First one is that is Wurtz-Fittig reaction, Ullmann reaction, Friedel-Crafts reaction, Williamson synthesis, Huffman ammonolysis. These type of reactions are called the name reactions. And name reactions are often asked in exams, and these can be asked in all the formats. First is like short notes, and second is like identify the equation and write the mechanism or discuss the mechanism of the following equation. So this is the first part, that is like a short note. So we will discuss these name reactions from haloalkanes and haloarenes. This is basically the first chapter that comes under the functional groups of organic compounds. There are several name reactions that may be in the method of preparation in chemical properties. So first we will now discuss the Finkelstein reaction. Finkelstein reaction is in the method of preparation of haloalkanes and haloarenes. Finkelstein reaction, that is iodoalkanes, are obtained by heating chloro or bromoalkanes with a concentrated sodium iodide in acetone. This means iodoalkanes can be prepared from chloroalkane and bromoalkanes. When chloro and bromoalkanes are treated with concentrated sodium iodide in presence of acetone, we can obtain the iodoalkane. This is the general equation where alkyl halide, where halides are what? Chlorine and bromine. When this is treated with sodium iodide in presence of acetone, this is converted into iodoalkane and co-product is sodium halide. If we take the example of bromoethane, when bromoethane is heated with uh, sodium iodide in presence of acetone, this is converted into iodoethane. Similarly, when chloroethane is heated with or refluxed with sodium iodide in presence of acetone, this is also converted into iodoethane. So this was the Finkelstein reaction. Second is Schwarz reaction. So in Finkelstein reaction, we have discussed that iodoalkane can be obtained from bromo or chloroalkane by reacting with sodium iodide in presence of acetone. But the formation of fluoroalkane is quite difficult. Fluoroalkanes cannot be prepared directly from bromo and uh, chloroalkane. So there is another method. Fluoroalkanes are prepared by treating alkyl chloride or bromide with salts. The salts are like mercurous fluoride, silver fluoride, cobalt fluoride, or antimony fluoride. It means when chloro or bromoalkane are heated with salts like Hg2F2, AgF, COF3, or SbF3, we can obtain fluoroalkane. First equation is when chloroethane is heated with Hg2F2, we can obtain the fluoroethane. Similarly, when we react bromomethane with HGF, we can obtain fluoromethane. So this is the Schwarz reaction. Next is Huns-Decker reaction. Huns-Decker reaction is when silver salt of carboxylic acids are dissolved in carbon tetrachloride. These are decomposed by bromine to form bromoalkane. This means silver salt of carboxylic acid when heated with or react with the bromine in presence of carbon tetrachloride, this will form the bromoalkane. Example, this is the silver salt of acetic acid. When this heated with bromine in presence of carbon tetrachloride, this will form bromo. This is not CO, this is CO2. This will form bromomethane. So this is the Huns-Decker reaction. And the yield of halide here, that is bromide, by the Huns-Decker reaction. The yield is primary bromohalide. We can find this in higher yield, then secondary, then tertiary. So in primary can be prepared easily, and this yield will be higher, and tertiary will be lesser. Next reaction is Bourbon-Simonini reaction. Bourbon-Simonini reaction is if in the above reaction, means in Huns-Decker reaction, if we take iodine instead of bromine, we cannot find the iodoalkane. This means we cannot find the haloalkane. So Bourbon-Simonini reaction is when silver salt of carboxylic acid react with iodine in presence of carbon tetrachloride, esters are formed. Here we cannot find the haloalkane. So in presence of bromine, silver salt gives bromoalkane, but in presence of iodine, this will form the ester. Example is, this is the silver salt of acetic acid. When this is treated with iodine in presence of carbon tetrachloride, this will form an ester, that is methyl acetate, and the co-product is carbon dioxide and silver iodide. So this is all for today. We have discussed 4 name reactions from the method of preparation of haloalkanes and haloarenes. First was a Finkelstein reaction, where bromo or chloroalkane, when treated with sodium iodide, this will form iodoalkane. Second was Schwarz reaction. This was the method of preparation for fluoroalkane, where salts such as Hg2F2, COF3, AgF, and SbF3 can be used. Third was the Huns-Decker reaction, when silver salt of carboxylic acid dissolved in carbon tetrachloride treated with bromine. There, that was bromoalkane formed. But when we take iodine instead of bromine, we can find the ester. So that is all for today. Now we are closing the session. We will meet in the new session with new name reactions. So if you guys liked this session, please subscribe the channel and share the video. Thank you very much.